Alright everyone, so here's what we have to do the experiment with. We are starting off with 0.53 grams of platinum black. Now, the method on Atomistry specifically says to use platinum sponge, and when I go and I check the literature from that time period, the definition of platinum sponge is elemental platinum powder that has been produced by the thermal decomposition of ammonium hexachloroplatinate or some other ammonium halide platinum complex. I guess you could also do it from the oxalate if potassium oxalate is indeed a thing. Anyway, but we're going to try it with this just because platinum black, the way that was written, I don't have a whole lot of platinum, and if I had done it that way, I would probably have about half of what I have here, and this is already going to be a very small amount to work with. I have dried it out a little bit using a heat gun just to try to get a lot of the water out of it. I don't know how wise that was, but I needed to be able to get an accurate weight of it so that I could at least have an idea as to what I was working with. What I have here is an equimolar amount of potassium ferrocyanide trihydrate. It's 1.15 grams. Basically what I am going to do is I am just going to pour that into the crucible with the platinum, stir it up really, really well, maybe add just like a drop or two of water just to dissolve a little bit of the potassium ferrocyanide and facilitate an even more intimate mixture of these two things. And then we are going to put it over the burner and we are going to heat it up to a red heat. That's what Atomistry says. Then we will allow it to cool, extract the melt with water, evaporate it down, and in theory that should be the hydrate of potassium platinocyanide. So, fingers crossed, there's a very good chance this is not going to work. But it's easy enough to recover the platinum, I guess, even though you always lose a little bit to mechanical losses every single time. But, yeah, I mean, it's worth a try. So I figured it was a worthy use of the last of my platinum, and I have wanted to try to make this compound for a very long time. This seems to be the most direct way of going about it, the most practical given what I actually have here. And this is the reaction that was used when this was discovered, although again, it was the sponge and not platinum black. So here goes nothing. Well, I guess I'm going to hold off on adding any water to it since I was able to get a nice intimate mixture just by adding the solid in there and stirring it up real well. Some water will come off of the potassium ferrocyanide trihydrate anyway. So, I really hope this works. Fingers crossed. Okay everyone, I'm not sure what this is, but we have some kind of orange compound here on the side of the crucible. I know that the camera it's not showing up really well, but this is like bright fluorescent orange in real life. Like, it is a far more vivid color than what you see on the screen there. This is like a really bright orange compound. I have no idea what it is. See, there's more of it here too. What's really wild is potassium platinocyanide is supposed to be a pretty fluorescent compound. And, I mean, is it really bright because it's fluorescing in the sunlight and the camera just doesn't pick it up well? I don't know. I'm intrigued at this point. This is really, really cool. And it seems to be kind of fading a little bit as time goes on. Anywho, I am going to extract the melt out now with water, and we're going to see what we get. Okay, everybody. This, believe it or not, appears to be it. I am unsure. This video still makes the cut because potassium platinocyanide is supposed to be yellow. However, I mean, potassium ferrocyanide is also yellow. So, I mean, how can I be 100% sure this is not the starting, just the stuff we started with? I am encouraged by one thing, and this is that potassium ferrocyanide begins to decompose from what I can tell, or boil. I'm not 100% clear. But I believe decompose at about 400 degrees C, which, with that micro burner on that, I'm not completely dubious that the mass, given how small it was, managed to achieve that temperature. It was a real pain in the ass trying to find a balancing act at which point this shit would not decompose, yet we still made sure the reaction went. Also, I mean, we did get that orange stuff at the beginning. I know, I'm sorry, the sun is kind of washing this out. And I've come to find out that the camera doesn't really capture it in exactly the same color that it's in. It does seem to be kind of bright, like almost fluorescent. And potassium platinocyanide, all the platinocyanides are indeed supposed to be fluorescent. It just seems like it is a very bright compound, much brighter than potassium ferrocyanide. So I am going to, and there would be more of it, except my clumsy ass accidentally jostled this thing and a little bit sloshed out. Not a whole lot. You can kind of see it on the burner there. See that? Yeah. Yeah. That's probably platinum right there. Yay. Anyway, I mean, I am very encouraged by the results. I don't really have a good way to know for sure. So the best I can say is this was incredibly encouraging. And given how much I desperately want to play with platinocyanides in the future, I mean, I don't know. I don't know that I'd really have enough platinum to make this way attractive. I will probably look at producing it a different way. But given that I didn't have any alkali cyanide on hand, this seemed to be like the best shot at trying it until I got some, so there you go. Anyway, if you like that one, give it a thumbs up. If you didn't like it, give it a thumbs down. In this case, I will understand. Subscribe, comment, share the video, and until the next one, y'all, I will see you later. It is pretty goddamn cool, though. Very encouraging indeed.